All right, welcome back, everybody. In this next video, we're going to take a minute and get started with actually doing some Android development for you. So there's going to be a couple of things you're going to need, though, before we get started with this particular assignment. First off, you're going to need the Android development environment, okay, or Android Studio. There's a link in that assignment, which you just saw me click right here. And you're going to want to download Android Studio. So if you get the latest version of Android Studio, right here, if you download this, the current version, and install it, that'll give us the majority of the things we're going to need for our application. So step number one is install Android Studio. Pause this video and go and get that installed. Once it's installed, then go ahead and resume the video. All right, welcome back. I'm glad you guys got Android Studio installed. That's element number one. The second piece we're going to need is to make sure we have our Android Studio functioning correctly. On this opening screen, yours may pop it up to begin with because it'll be your first time running it through these steps. If not, you can hit Configure in SDK Manager. And this will show you all of the different Android SDKs. Now, as you'll remember before, as I mentioned, we are going to need to pick a version, an Android SDK, to develop against as our target. And we're going to use Android version 21. So you won't have a checkbox here yet, so go ahead and check Android version 21. I'd also recommend that you have the current version, or if you're going to be developing on your own physical device, it's a good idea as well to have the checkbox for the version that device is running on, as it will just make it a little bit smoother for development on that. So make sure you get those versions checked, and then we can get the tools installed as well. One of the big ones, especially if you're not using a physical device, is to make sure you get the emulator installed. Hopefully you have a good Intel machine, because these emulators are running on Haxum, which will make the devices run pretty smoothly. If you are on a AMD machine, I'm sorry, performance is terrible. But the Android emulator works pretty well on an Intel-based machine. Likewise, we'll want to make sure you have the emulator, the platform tools, and the SDK tools installed. When you install the emulator, it'll ask you to install this one, the Haxum, the Intel x86 Emulation Accelerator. It'll ask you to do that. The last thing to make sure you have checked is this support repository. So again, we want to make sure we have the emulator, the SDK platform tools, the SDK tools, Haxum if you need it, and then the support repository, which will contain these 4 child libraries. Once you've checked all those boxes, go ahead and press OK, which will go ahead then and install all of those libraries for you. Again, pause the video because that can take a fair amount of time, especially if you're downloading several different versions at once. It may take you a minute, so go ahead and pause the video and come back when you're done. Okay, welcome back again. So now we are going to start a new Android Studio project. Okay, we want to start from scratch. In the anatomy of an Android application, there are several key pieces. Piece number one is the name of the application. Our applications are going to follow a naming scheme called, where we're going to do CS37, 3270, because that's our class, followed by the assignment number. So, for example, if this one will help us get started on assignment number 1, we could do A1, or whatever the name of your project is. Now this domain this is what we're going to build our package name off of. If you notice, we have a domain name here, but this builds our package name. Packages are how Android keeps all of the different applications separate. It's similar to how URLs keep different people's web properties separate. The applications will be the same thing now, but with packages, based on the domain of the application itself. Because you'll notice this piece of the package right here is the same as my company domain in reverse order, followed by my application name. Okay. One key thing I want to talk about, though, is your project location, and this is a big deal here. Okay. Your domains, your project locations, all of those things cannot have spaces. Okay. No spaces. You put a space in there, and weird juju goes down. okay, and you're going to end up with lots of problems and things that you'll be really, really frustrated dealing with, so just don't even go there, okay? No spaces, even if that means you have to make another place. For example, I like to make a directory on the root of my drive, and I call it Android, and I put all my projects in a project folder on Android. Okay. Now, when you change that the first time, that will attempt to put this thing in the projects folder. So you're going to want to make sure to put back into, say 3270 A1. Oops, I still have one in here from last time we did this class. Let me go delete my old A1 because we don't need that. Goodbye. There we go. A1. Okay. We don't need C++ support, and we don't need Kotlin either, so we're going to go ahead and press Next. Okay. Now we need to select the form factors and minimum SDK. We're going to choose for this particular one, we want to target just phones and tablets, and then specifically we want to target API 21. Every assignment that you'll accomplish this semester is going to target API version 21, which, as you can see, will run on approximately 71.3% of devices. This gives us a pretty good balance of relatively new Android environment, pretty solid set of capabilities without having to deal with all of the weird things that come back with some of those older versions of Android. So we're going to pick those, okay? Phone and tablet, Android API 21. Now, when you first come here, then the next step is you're going to be able to set up some boilerplate templates that it can choose from, such as a basic activity, a bottom navigation activity, a maps, a login, add mob, full screen, master detail flow. Like you guys can go through these at your leisure. That's going to set up a ton of boilerplate code, and at this point in the game, that's just going to confuse the daylights out of you. So we want to pick just an empty activity. So make sure you got the blue box around empty activity and go ahead and press Next. Okay, we're going to need now a name for our empty activity. By default, the convention you'll see oftentimes is main activity for just the primary activity that drives everything. If you happen to be writing an application with several activities, then you need to name them appropriately. Well, let's go ahead and let Android generate a layout file for us for this activity or this main activity. And typically when we deal with layouts, they are the type of layout or the thing that's making the layout, such as activity, followed by an underscore and the name of it. So later on, next week when we start dealing with fragments, you'll see fragment underscore and then whatever its name is. And because we're wanting to target backwards to API 21, make sure this checkbox here is selected for backwards compatibility. Go ahead and push Finish. And this will set up all of the structure for the application. You'll notice it'll take a few minutes to doing some downloading from Gradle. Gradle is a build tool that we're going to talk about here in just a minute. If you've taken, say, like a PHP class, for example, and you've dealt with Composer, or, I mean, a lot of languages, typically you'll have now a tool that manages dependencies. And that's what Gradle is all about, is managing the dependencies of an application. Over on the side of our project here, when we're in Android view, you can see there's several different views. We can be in project view or packages view, problem view. We want to come to Android, okay? And you can see there are two different build files. Build.gradle, and let's put in parentheses the project, okay? Very rarely will you have to do anything with this particular build file. Most of the time you'll be dealing with this app, okay? Because this is going to be the thing that turns the code you write here into an Android application. And you'll see some now that we told it we're targeting compiling against Android API 27, but our target is 21, our minimum. We can apply a version code, our package name that we want it to have for this application, as well as later on, and we'll do more of this later on throughout as the semester goes on as well, but other libraries or other things we're dependent on, we're going to put here in this dependencies file. And Gradle will be responsible for then, say for example, finding the constraint layout library, downloading it, and compiling it into our APK when we're running. Likewise, you can see we have test implementation for just standard JUnit tests, or we have Android test implementations when we need to run Android-specific unit tests. We may or may not make it to unit tests. We'll have to see how the semester goes. There's, as I've mentioned in the past, a lot of ground we can cover in Android. So element number one of an Android application here in the IDE is your Gradle and especially this Gradle file, because it's going to provide all of the configuration for your application itself. Now, projects themselves, if we come over here into our app and we expand it down, are broken into one of three main categories. Element number one, the manifest. As I mentioned before, the Android manifest will describe your application to the virtual machine that's running your application. So we can give it knows the package that it belongs to. You can see in the application all of the activities. This is an XML file, so as more activities went in place, they would land in here. And it knows this is the main activity because we have action main and launcher both attached to this main activity via our intent filter. We define, like for example, what icon to put in here and other things like that happen as well in the Android manifest. And it will also fill in a lot of other details now that are defined in our Gradle build file. Okay. So element number one, we're going to have our manifest. Element number two is under Java. You can see here, we're going to look at the one with the white background, not the two green, because those are testing. But we can see now the structure of our code. For example, our main activity. We can see, as I mentioned before, we extend, right? We're all about inheritance in Android. So this main activity is going to be the thing we want to drive or to draw on the screen. And Android will know how to work with that because we are extending app-compat activity or a backwards compatible activity. We don't want to target just the most recent version of activity because we're compiling, remember, with version 20 or API 27, but we also want to support all the way back to 21. So by supporting or extending from app-compat, that's exactly what we do. Now, the activity itself is going to go through several life cycle events, and we're going to be talking about the life cycle events real heavily next week. I don't want to get into that too much this week and confuse you. But if you want to get a jump, go read about the activity life cycle. It's one of the most important things you can learn in Android development and also one of the most complicated elements to first wrap your head around. And I definitely want to make sure we don't have that be a stumbling block for any of you. Okay? But one of our life cycle events is the onCreate event. Now, Android follows an event-driven paradigm. Okay, this is very different than the procedural paradigms you've encountered in other classes. Meaning methods and capabilities and other things like that will not be invoked or won't be used unless some event triggers it. Okay, when something happens to tell the operating system, hey, do this thing, then the operating system will react and accomplish that task. For example, when the activity is first being created, there's an event that says, hey, I created an activity. What do you want me to do with it? Well, our child activity now needs to tell the operating system, well, this is what you do. This is what makes our activity different than every other activity. And it will fire the method onCreate where we can do whatever we want. In this case, we're really only just telling it, here's where you find the layout file of what my activity should look like once it's run. Okay, and that's that activity main, and we'll look at that in just a minute. Okay. But other than that, this should look like pretty standard Java. We've got our imports at the top, our package declaration, our class declaration, and then one single overridden method for now. The third area, okay, again over on the side here, right, we had element number one, which is our manifest, number two, which was our code, the Java section, and number three is where we're going to encounter resources. Now, the resources themselves in an Android application break down into 4 areas. We're really going to deal with 2 of those to start, and then we may throw in a third one later on. Drawables is where you're going to put things like images, okay, are going to go in there. Layouts, we're going to put layout files. Values, we're going to deal with strings, or if you want to define a styling to it, provide default spaces, and sizes to things. All those elements will go into values. In fact, if you expand it down, you can see default colors, strings, and styles belong in there. The 2 that I really care about for today, we'll get to the other ones later, is the layout folder and the values folder. Those are the 2 we're going to care about. Okay, and that's the basic structure we're going to deal with here in the IDE. So if we go ahead and we look at our activity main XML file. Now, in this, there are 2 different views or 2 different ways of looking at this layout file. Okay, Number one is the text view, and you're going to spend a lot of view in here. I know a lot of students get excited. They see that design tab and they go, sweet, drag and drop, WYSIWYG. Not so much, okay? It's great for dropping down and getting maybe some boilerplate pieces in place, but the reality of the situation is you're going to spend a lot of time editing the XML files themselves because the graphical tools, while Google has made great leaps and bounds with them, they kind of suck in real life, and you can cause lots of problems and get yourself in all kinds of tangles really, really quickly. But the design view is useful because it'll let you see a basic rendering of what your application is going to look like. For example, we can see we've got the Chrome of the application, of the operating system, meaning that the status bar where you got the time, the battery, all those types of things, as well as the soft key buttons. Those are known as window Chrome. We've also got an action bar across the top with the title of our application. And then right now this application is using what's known as a constraint layout. This is why we have those squiggly lines, because we're telling it to center this particular piece of text and our hello world text. We're actually going to change that layout in just a little bit. But this, so you can see what that layout, what this looks like from that particular point of view. Okay. So, well, the designer view is great because then, for example, if I wanted to drop out, something like an image view, I could come in and I can drag and drop it, and it's going to say, okay, where's that image coming from? I don't have any, so it's maybe a bad pick. How about a button? We can drop a button in place, and it will put the button in my text, so I can come in and now fill in the necessary details. So the designer view is useful from that perspective, but we want to be careful not to rely too heavily on the designer view. Okay, you can spend a lot of time in this text view. All right, so we want to start simple. Now, by default, when you first build an application, Android, when they developed their templates, they built those for what you're going to use frequently in real-world projects. Okay, and the constraint layout is an incredibly powerful layout manager, which means all of the different views or widgets that you're going to put in it as childs, the constraint layouts figures out where they go on the screen relative to one another. The downside is it's a little complicated to wrap our heads around, so especially for this first couple of assignments, I don't want you guys to worry about the headaches of constraint layouts. We'll come back to them later once we have a little bit more underneath our belt. Instead, I want to spend a little time on what is arguably one of the most powerful layouts and most commonly encountered layouts that you'll see in the real world, and it's known as a linear layout. So we're going to come in here and change android.support.constraint layout to linear layout. Okay. Now, in the layout itself, and in pretty much every UI element, there's a couple of common things that I want to point out that you're going to see. First off, at a minimum, on the first node, we're going to define some namespaces. We've got Android app and tools that will help Android know how to interpret the argument or the attributes that you apply to this XML tag. But two of these are going to belong on every UI piece you make. Specifically, the layout width and the height. Okay. Now, there's several ways we can approach this. For example, right now it says width and height are both match parent. Now, match parent means take all of the available remaining space and use it. So this linear layout is the first layout involved in our hierarchy, and by saying match parent, I'm saying take all of the space, use everything. Okay, match the parent, take everything that's left above you. If I didn't want to do that, the other option is I can say wrap content to say shrink yourself to just the minimum amount of whichever piece you need. For example, I could say my height still is match parent, but my width could be wrapping content. We'll also get into more advanced versions of those, and how to do like ratios and all those other things, because in CSS you're so used to saying like 50%. Well, we don't do that in Android. We have a different way to approach it, and we'll get into that next week. So for now, we want to be aware of both of those pieces. So for this particular one, we want our layout to consume the entire screen, and then we're going to put a text view in it. In fact, whoops. What in the world? Go away. If we come back to our assignment, I've got our first assignment essentially is a hello world. Okay, where you're going to come in and you're going to modify your application so that it says the assignment and your name, last name, as well as now it says hello and then your name here as well. This is kind of what we're looking for. Now, we've started on that by providing a linear layout, but let me explain the way linear layouts work, okay? If we had, for example, here's our Android device. Linear layouts, there are two types, okay? And we're going to define this in just a moment, okay? Where we have to tell it is either horizontal, whoa, that's a funky Z. It's hard to write vertically on a screen. Horizontal or vertical, okay? A linear layout just takes the children and stacks them on top of or next to each other, depending on whether you said horizontal or you said vertical. So if I say I am dealing with a vertical linear layout, I'm going to take children and stack them on top of each other in a vertical fashion. If I have a horizontal layout, I'm going to stack them side by side by side, all of the children that are nested within that linear layout. Okay. This linear layout is going to be pretty simple because I only have one text view in it for now. But we need to tell it whether we're dealing with vertical or we're dealing with horizontal. Now, if you hit Control Space on your keyboard, this will bring up all of the attributes we could potentially apply to the situation that Google or that Android Studio is finding. The one we want in this case is orientation. Okay, the orientation of this layout, and we're going to do vertical, which is what you'll use very frequently. Vertical linear layouts are probably one of the best, most versatile tools you can have in your layout toolbox. Go away. Don't want that. There we go. Okay. Now next, inside of our linear layout, we're going to have a text view. A text view is a widget, okay, that provides the ability to put a piece of text on this screen. Now, right now, because it started with a constraint view, it has all of these elements that are required for constraint views. We're going to just delete those because we don't need them, okay? At a minimum, we need these three pieces: a width, a height, and then some value that we want our text to contain. Now, I want you to pay really careful attention, okay? It means if you're off in La La Land right now because you've developed Android apps before in the past, pay attention right now because you need to know this piece because your grade will be affected by it, okay? One of the worst practices you can get into, and I cannot tell you how many developers I've encountered who started doing things lazily and then never have managed to break out of these habits and have caused problems after problems in the future, okay? Specifically, right now our text here is hard-coded. If you submit any assignment containing hard-coded text, that will be immediate loss of points, okay? We want to support the ability to handle localization, and I need to teach you best practices, and this is one of those ones the industry has asked for. Because having hard-coded text, whether it's in an XML layout or in Java files later on, creates a nightmare for everybody who comes after you to figure out where in the world things are coming from. Because strings should belong in the strings resource file over here in the values folder. Okay. Now, luckily for you, Android Studio makes this really easy to fix. In fact, there's a little light bulb over here complaining, saying, hey, you've got, something we need to fix. Specifically, we can extract this string resource and we can give it a name. Let's say hello for our string name, and it will populate automatically with a value. It's there, and now it will replace that text with a reference to our string resource and specifically to the hello entry. In fact, if we open our strings.xml, you can see that now. We have the app name of our strings file, which is what shows up in the bar, and then we also now have our hello string that we just made. So now whenever we want to reference the words hello world, if we point to @string/hello, that text will be there. Or if I want to change that, if I edit it in my strings file, and it's automatically then updated everywhere that uses that particular piece of text. So let's go ahead and run this. Now, if you're on a physical device, I've got a link to show you how to do that as well. You can read it. It's super easy. You just have to make sure you have the right drivers installed on your computer as well as enable developer options. And I've got a link that'll walk you through how to do that since I can't really broadcast my screen very easily in a video recording for you. But for those of you that are going to be doing this with the emulator, okay, we're going to click this little button. This Android looks like he's got a purple box behind him. It's supposed to be a phone, and that's the Android Virtual Device Manager. You guys probably won't have devices unless you've already done some, so we're going to come in and create a virtual device down in the bottom left. Pick a device you want. It's nice to pick one with the Play Store, so you got Play Store APIs. For the kind of stuff we're going to be doing on these first handful of assignments, you won't need that till later on. So if you want to pick a non-Play Store compatible API or image, take your pick. Pick a size that looks good to you, and then pick an image that makes sense. So for example, this, if I'm running on NuGet, I can see that there. Or if I wanted to say run this on API 21 that we're compiling against, I would download that image of Lollipop. And this takes a minute. And we're going to go ahead and hit finish now. And now we can choose, we can see that from our images, right, we can choose our Lollipop because it's bolded right here. Now it recommends for this particular device using NuGet or Oreo. NuGet's what it shipped with, but Lollipop will run on it just fine. And we can say the name of the device, API 21 for example, and hit finish. Now if you want to do some advanced settings, you're welcome to do some of that stuff that, for example, if you want it to be able to access like your webcam as if it were the camera of the physical device, or you want to, pretend you're on an old school GSM network or an LTE network, you can do those types of things. Set how many cores it has, RAM, all those other pieces. If it has an SD card, the ability to type on your physical keyboard versus having to use the touch or the soft keyboard with your mouse. All those pieces. Finish will go ahead and build our AVD. Now the first time you launch that by hitting this green button right here, it's going to take a good while because it's got to boot up Android. Okay, because you're running in an emulator now, so we're using a piece of software to pretend to be physical hardware. So as far as Android goes, it's not aware of the fact that it's not on a physical piece of hardware. It's going to think it's an actual phone. To save time for our video, I'm going to launch one that I've already launched, so we don't have to wait for it to do a cold boot. Oh, of course, that's ironic. It wouldn't take my snapshot. Something got corrupted, so now it's going to do a cold boot. That's really funny. API 24 is a little bit faster to start up anyways. So we'll run with that. So you can see the device now is running, and it's just like any other Android device. I can pull up my app tray. I can open up the Play Store. I can sign in Gmail. I can surf the browser. Sometimes students are having problems with network connectivity. Make sure your mobile data is turned on, or the Wi-Fi on this particular device is turned on. It's not going to let me turn on Wi-Fi. Oh well. We go chase it into settings. I don't want to take the time in that in the video. Just make sure you've either got cellular data or Wi-Fi data if you're not getting network connectivity on your emulator. That's by far the most common problem that students run into. Okay, we've got an emulator running on, and now we can hit the big play button right here, which will compile a version of our application and deploy it. It's going to come up and ask you, where do you want to deploy it? So I've got this API running, or this virtual device running, or I could boot one of these two. I want to go ahead and just deploy it on the one that's already open. And we'll have to wait for just a minute. Now it's going to do a Gradle build. This first time you do a Gradle build, it'll take a little bit longer than other times because it has to go out and download all of your dependency information from the internet, cache it on your local computer before it can then compile things and package an API and then now ship it over to our device. So we can see here we've got the basic pieces of our application. And if we want to change that text, as I mentioned before, we can say, "Hello world, how are you today?" And we can run our application again. If you're going to be testing on the same device over and over again and you get sick of it asking you, there's a checkbox right here that says use the same selection. Go ahead and press OK. and it will go ahead and rebuild. Notice how much faster that was. And now my text is updated to show me what I have there. Now, when you turn in your applications, one of the things I require is you take a screenshot of your application showing me that you've got it up and running. This is pretty easy to do. You've got when your device is running right here, we can hit the little icon, which will take a screenshot of your device. Personally, I prefer, however, to let's get that go away. Under Tools, where's Android? Am I blind? It just updated to a new version of Android Studio before we started started this recording today. I must have Android open on the sidebar here somewhere. Well, it looks like it's not installed on this machine. So we're going to just roll forward. If you hit the little screenshot button here when you take those, you can see I'm taking several screenshots. By default, that's going to place that on your desktop, and here's all those screenshots. If you want to see where that location is, if you hit these three little dots right here, you can see screenshot save location, and that'll tell you where it's putting them. Or if you want to change it, go ahead and put them wherever in the world you want. That's up to you. So you'll take screenshots and you'll apply those, or you'll upload those along with a zipped up version of your entire project. We're going to later move to GitHub for project submissions, but for now we're going to use just zipping these up for the first couple of weeks, and then we'll move over to GitHub. But for now, that's what you need. The last thing I wanted to show you is sometimes with your text view, we can start to do more. One of the things, for example, if you look at this, the text is kind of really close to the edges, the top and the left there. It's kind of hard to read. So maybe we could make that, we can move that a little bit. One of the easiest ways is we can use that with margins, or we can do padding. So for example, if I want to do a margin, and you'll see it'll come up and start to suggest, I can do margin bottom, end, horizontal left, right, start, top. Now if you chart, you can do left and right, but Android will complain about those. Specifically, you should be using stop or start and end. For example, if I want to put margin start, meaning at the beginning of my text. Now they do that, for example, if your application is localized to a language that reads right to left rather than left to right. But I could say, let's apply 16 density pixels to the start, and let's add some margin now to the top as well. Let's add another 16 density pixels. And if we deploy our application again, you'll see our text now has moved over 16 dp and down 16 dp. So we can control the movement of things through margins, okay? So just as a reminder, okay, now if you were to submit this application and you actually contained the string, something like this, hello, Josh Jensen, okay? If you have a hard-coded string like that, okay, and it's going to turn yellow like this and warn it to you, okay, if you have a hard-coded string, oh, I don't want a semicolon there, that was stupid, that's an instant loss of points, okay? We don't want hard-coded strings. Go ahead and make sure to extract those out, okay? If you don't want to hit the little button, the light bulb, you can also press Alt-Enter, okay, as a keyboard shortcut. Alt-Enter, and then choose Extract String Resource. And now we have a string resource. You can see in our strings, we've added a new one now that says, hello, Josh Jensen, which is this new one that I just extracted now, okay? So that's it for this particular video. Next week we'll start moving on in fragments and other more complicated things, so please make sure you get, I know this one's simple, but make sure you get everything running as we've talked about it today, so that we know your devices and your student environments and everything are up and running. Thanks.